This is AI Podcast. I'm Ethan, and today we're talking about a new AAAI paper on pairing large language models with optimization. Big picture, it asks how we get from messy business questions to math that makes good decisions.
I'm Maya. Give me the quick headline first. If I only remember one thing, what is it?
The takeaway is that large language models can help non-experts start an optimization project, but they still need scaffolding to make the math correct and efficient. The authors call the vision a decision optimization co-pilot.
A co-pilot for decisions. I like that. Who's behind the work?
Think IBM Research and the University of Amsterdam. One of the leads is Segev Wasserkrug, and the group includes well-known optimization folks like Dick Den Hertog.
All right, set the stage for me. What problem are they trying to solve in the real world?
Picture a hospital manager saying we need to place vaccination clinics so people do not travel too far. Or a city planner deciding where to put bike rental hubs. Turning that plain language into a precise model with objectives, constraints, and variables is hard. It usually requires an expert who speaks both business and math.
And the pitch is that an LLM can act like a translator in that first mile.
Exactly. The model chats with you, asks follow-ups, suggests the type of optimization you need, and drafts the formulation. But the authors point out three things this co-pilot must do well. First, translate business goals into a proper model. Second, check that the model is actually correct, in a way a non-expert can understand. Third, produce a formulation that solvers can handle efficiently.
That third one is the sneaky part. What does efficient mean here?
Think of it like two recipes that make the same cake. One is 5 steps and uses common tools. The other is 20 steps and needs a blowtorch. Both are correct, but one is practical. In optimization, two formulations can represent the same decision problem. Yet one will run fast and the other will crawl or fail.
Got it. So how did they test this idea?
They ran small, illustrative experiments. For the translation piece, they played the role of a business user and asked a large language model to figure out a bike hub location problem through conversation. For correctness, they gave the model clean, precise problem statements, like clinic location and radiotherapy planning, and checked whether the objectives and constraints came out right. For efficiency, they asked the model to rewrite a correct formulation into a solver-friendly version, for example, to reduce unnecessary variables or linearize tricky expressions.
And how did it do?
On translation, the model had good instincts. It asked sensible clarifying questions and moved toward the right family of models. But when it wrote the math, it sometimes missed key constraints or mixed up indexing. That means a non-expert would still need help validating the result.
So it is a promising conversation partner, but not a certified modeler.
Exactly. On correctness with those precise statements, it produced solid formulations most of the time, but occasional mistakes were subtle. Things like a slightly wrong objective or a constraint that sounded right in English but did not bind the variables. Those are the kinds of errors that slip through unless you have checks in place.
The kind of mistake where you do not notice until the solver gives you an answer that looks suspicious.
Right. For efficiency, the model struggled most. It could sometimes propose a more compact or linear version, but it also introduced non-linearities by accident or dropped needed binary variables. Efficiency is not just writing the math. It is knowing reformulation tricks that seasoned operations researchers collect over years.
So the co-pilot vision hinges on more than good chat. It needs a safety net.
Yes. The paper frames it as 3 requirements. First, better elicitation so the system pulls the right details from the user. Second, verification tools that explain the model back to the user in plain language and run tests. Third, a capability to search for or learn efficient formulations, not just any formulation.
Let's unpack those. For elicitation, what would a good system ask?
It might ask about objective priorities like, do you want to minimize travel distance or cost? It would probe constraints, such as maximum number of sites or equity targets. It would confirm what data is available and whether uncertainty matters. The goal is to turn a messy wish list into a clean blueprint.
And for verification, we are talking about show and tell.
Yes. Imagine a tool that highlights a constraint and says this is the rule that caps the number of clinics, then shows a small example with fake data to prove the constraint behaves as intended. Or it runs unit tests for the model, just like software, to catch silent mistakes.
I like that. And the efficiency piece. How do you teach a model to be solver-friendly?
2 paths. One is a library of modeling patterns. For example, how to linearize an absolute value, or how to express a max term without blowing up the variable count. The other is learning from experience. Use data from past problems to pick good formulations and solver parameters, almost like a tuning brain that sits next to the LLM.
That sounds like an agent team. One agent talks to the user, another checks the math, a third tweaks the formulation and runs the solver, then they loop.
That is the spirit. The paper leans into agentic workflows and solver in the loop feedback. The idea is to make modeling a guided search with tests, not a single-shot prompt.
Let's be honest about limitations. How strong is the evidence today?
It is early. The experiments are small and illustrative, and they use one general-purpose model, promising signals, but not a definitive benchmark. Reproducibility is also tricky because conversations vary with prompts and settings. The authors are open about that.
So the claims are careful. Useful direction setting, not a grand slam result.
Exactly. And there is plenty still to test. Head-to-head comparisons with existing natural language to optimization tools, more diverse problems with uncertainty and fairness constraints, and measures that include both accuracy and runtime.
Let us ground this in a real example. Suppose I run a grocery chain and want to decide which stores get electric vehicle chargers. How would this copilot help me?
It would start by asking what you care about, maybe maximizing coverage of customers while staying under a budget and ensuring each neighborhood has fair access. It would suggest a facility location model, ask for data like store coordinates and expected demand, then draft a formulation. Next, it would explain each constraint in plain English, run quick tests, and offer a more efficient version if the first one is bulky. Finally, it would hand the formulation to a solver, return a proposed set of sites, and let you run what-if scenarios.
And if I say the city just introduced a rebate if chargers are near transit, it would treat that as a new constraint or a tweak to the objective.
Right. The magic is the fast loop from business change to model change, with checks along the way.
One thing I hear from practitioners is fear of hallucinations. What keeps this from being a confident but wrong assistant?
Guardrails. Verification by construction, not just after the fact. Traceable mapping from each business rule to a constraint. Unit tests with small synthetic data. And conservative defaults, like refusing to proceed until every constraint has been validated with the user.
So a polite copilot that says, "Let me show you what I think your rule means, and please approve it."
Exactly, a partner, not an oracle.
Before we wrap, what do you see as the most impactful next step for the field?
Shared benchmarks that start from messy narratives and include ground truth formulations, plus solver traces. If we can measure translation quality, correctness, and efficiency together, progress will accelerate.
My vote is for better user experience. Let non-experts click on a solution and hear a plain language explanation of what changed and why. If you show the business impact clearly, adoption follows.
Both are needed. Strong measurements under the hood and a friendly cockpit on top.
Quick recap for listeners. Large language models can help kickstart optimization projects through conversation. But to be trustworthy, we need systems that elicit the right details, verify the math in human terms, and deliver solver-friendly formulations. Early tests are encouraging but small, and the road ahead is benchmarks, agent workflows, and better UX.
Nicely put. That is our show. This was AI Podcast. If you enjoyed the discussion, share it with a colleague who still thinks optimization is only for specialists.
Thanks for listening. We will see you next time.